Levers are where we'll are where we'll mostly see torques applied, and levers occur many times throughout the body. They're a type of simple machine. Sure, you studied levers even as an elementary student. They allow a person to either increase a force or increase a displacement. Increase, you get that. So we have three classes of levers, and they will be classified by where their fulcrum, the load, or the resistance, or the effort is. So make sure that you know these three classes of levers. These are the class 1 lever, class 2 lever, and class 3 lever. The class 1 we've already seen, where I have the effort on one side and the resistance on the other side, and then my axis of rotation, or my fulcrum, is right there. For a class 2, my effort is here and my resistance is here, and then my axis of rotation is on the end there. And then for the class 3, my effort is here and my resistance is here and my axis of rotation is right there. So make sure that you know those. Here's some examples. A, uh, a like a what's that called? Like a seesaw or a lever that you move things like a stone like this. A wheelbarrow is an example of a class 2 lever, and this type is like a digger or whatever. Let's look at this overhead machine press. This overhead machine press is a type of lever, and in fact, it can be misleading because while you might put 25 pounds or whatever on your overhead machine press, or 100 pounds or 200 pounds, I don't know how much you put on there, but that the force required to push it up is going to actually be less than the actual weight that you place on the overhead machine press. So let's draw a cartoon version of this first. Um, I've sort of done it here a bit. This is my axis of rotation. Here's my resistance force, and then this is my effort force. So I'm going to draw it over here. There's my axis of rotation. My resistance force is right there, and then my applied force is here. So this force is equal to 25 pounds. By the way, what type of lever is this? Is this a class 1, class 2, or is it a class 3 lever? Well, I know it's not a class 1 because my axis of rotation is not in between the effort and resistance. So it's either a class 2 or class 3. It's a class 2 because the effort is out here and my resistance is right here. In fact, a class 2 lever is always going to require less weight in the effort than you have in the resistance. And the opposite will be true for a class 3 lever. I'll do an example of a class 3 here in just a second. So here, let's just sort of assume some distances here. Actually, I don't even really need to assume any distances. I'm just going to make some assumptions about the relative nature of the distances. So let's say that this distance is r, and then this distance appears to be about twice that distance. So I have 2r. Now, the torque due to the effort, I'm going to call that T effort, should equal then the torque due to the resistance in order for this to be a static system or in equilibrium. So the torque due to the effort is going to be force, I'll call that effort, times 2r, and then that's going to equal my 25 pounds, which is my resistance, times r. Notice here that my r's cancel out. I can divide through both sides by r, and then I can calculate my effort is going to be 13 pounds. So you only have to exert 13 pounds in order to lift a 25-pound plate. Now, let's assume that instead of having a class 2 lever, let's say that we have a class 3 lever, and a class 3 lever would look different. I still have my axis of rotation here, but my effort would be here, and my resistance would be there. That is a class 3 lever. And then what is the effort required to lift that? Well, let's say that I still have the 25 pounds here, and I want to know what is my effort, and we'll use the same distances. So the force effort times R will equal to the force resistance times 2R, right? Because the distance from here to here is twice the distance from the effort to the uh, axis of rotation. Then I can solve this. My resistance, I'm going to go ahead and put in 25 right there. Notice my R's cancel out. And my effort force then is equal to 50 pounds. Right? Have you ever seen somebody where they have, where they're lifting a dumbbell, right? You have this guy or lady, and they lift this thing up over their head. This is also, well, this would be a class 2 lever, right? But if you try to lift it instead over here, then it becomes much more difficult. Right? And that was a year or two ago, that was like an internet challenge, is can you lift a dumbbell from the end or a barbell from the end? And it's actually very, very difficult, even if you don't have much weight on it, because that class 3 lever, you just lose a lot of your mechanical advantage.